like it?
Well, it certainly looks very nice.
I think it's lovely. Is it really all made out of steel, Dad?
Yes, practically all of it. By the way, they were awfully nice at the Morris Works. They showed me all over the factory.
Oh, how
Apparently
nice.
they welcome visitors.
How awfully interesting. I wish you'd taken me.
Well, let's have lunch and then I'll try to tell you all about it.
Oh, yes, that would be lovely.
That's better. And now for a nap.
Oh, no, you don't. What about that car you were going to tell me about?
Oh, yes. All right, then. Well, here goes. Now what shall I call it? I know, the story of your Morris 10. Well, imagine a row of furnaces, all as big as an average room. A wave of terrific heat and a blinding glare emerge as one is opened for a fresh charge of pig iron to be loaded into it. This is done by a machine which lifts a box of iron and thrusts it into the furnace. The glare is so intense that the men in charge have to protect their eyes by wearing special blue glasses. When the metal is raised to the proper heat, the furnace is tapped and out pours the molten contents. This is a most awe-inspiring sight. The metal rushes from the furnace with a roar like some wild animal, and as it falls into the ladle, bursts into showers of sparks. You have to be very careful not to get too near these, as each spark is a piece of molten metal and could cause a very severe burn. Each tapping represents something like 50 tons of metal, and when the furnace is empty, the huge ladle, which is on rails, is moved over a series of molds which are sunk into the floor between the rails. As soon as the ladle is in position, the men who are in charge open the valves and outpours the metal into the molds below, presenting a magnificent spectacle. Each filling is accompanied by an explosive roar, and a cloud of smoke and sparks silhouettes the workers. The metal is left in these molds long enough to allow it to solidify, and the ingots, although still red hot, are then lifted out by a crane and carried to the rolling mills. The main feature of these mills is a pair of extremely heavy rollers. On either side of them is a power-driven track capable of being driven in either direction, and anything placed thereon can be passed backwards and forwards at will. As soon as the ingot is placed on this track, it is fed up to the rollers, which are opened just enough to allow it to pass through. The ingot is then passed backwards and forwards, and at each pass the top roller is lowered slightly, thereby squeezing the metal. At the same time as the rollers are being closed, the ingot is turned over, and gradually, from an almost rectangular shape of red-hot metal, it becomes an elongated bar. Continuing the process in a pair of finishing mills, it becomes a long sheet of metal about 1 inch thick and approximately 100 feet long. It's a wonderful sight to see this length of red-hot metal sailing backwards and forwards through the rollers. When it has been reduced to the required thickness, it's passed through a cooling bath and then cut up into short lengths on a power guillotine. And now commence the various series of operations which reduce it sufficiently to make it into a motor car pressing. This again is done by passing it backwards and forwards through a further series of high-powered roller mills. The complete process is far too long to describe to you in detail, but it's sufficient to say that the metal is rolled and heated and rolled until the sheet has been reduced to the necessary dimensions. The heat treating of the metal is to make sure that it has the correct degree of plasticity. At the conclusion of these reducing operations, the sheet is passed through a machine which stretches it and thus ensures a perfectly flat sheet. Before these sheets are used, however, they are subjected to a keen scrutiny, and any which have the slightest blemishes are rejected. The Morris standard ensures that the OK stamp is placed only on the best. And that's how they get beautiful, flat sheets of steel.
But, Dad, the car hasn't got flat sides. It has beautiful curves.
Yes, I know, Miss Inquisitive. I thought you'd want to know how that's done. Well, those beautiful curves you like so much are made on huge machines called presses. Some are as tall as a house and weigh as much as 30 tons or more. In the press shop, there are rows of these huge monsters, all so ponderous and operating so slowly that it seems very improbable that they could ever produce the kind of work they do. The whole principle is the same as your mother uses to cut out pastry on the kitchen table. You know how she first makes a slab of pastry and then by pressing a cutter into it obtains the required shapes. Well, that's precisely the same method which is adopted for the metal. Take, for instance, a door. First of all, a die is made to fit the exterior and then another to fit the interior. Thus, two pieces of metal are obtained which are practically a dead fit in one another. These are then placed in a press, one onto the bed of the machine and the other attached to the ram above. A sheet of metal is placed on the die that is on the bed of the machine and the top die is forced into it, thus producing a door. Amid a noise that only sheets of metal can make, combined with overhead cranes, small motor trolleys and the noise of the presses themselves, a continual stream of body parts leave the machines and are conveyed to the body assembly shop. Thus, from flat sheets of steel, they get side panels, floors, roofs and doors, and it only remains to assemble them into their proper places to produce a car. Before the main assembly can be started, numerous small sub-assemblies have to be completed. These, such as doors, windscreens and the floor itself, are all assembled in small machines called jigs, which ensure that the parts are properly located in relation to one another. Some assemblies, such as the chassis members, are completed in an electric flash welding machine. The two parts are clamped firmly together in one of these and the current applied. This results in a spectacular display of sparks, and the two parts become welded into one. And now we come to the assembly of the body itself. The first step in this direction is to locate the side members by means of the shackle pin holes with steel plugs. As soon as this is done, the sub-assembly of the car floor is placed in position by two operators, while a third man rapidly secures the dumb iron cover ready for welding. When the constructive assembly is complete, operators pull down electric welding machines which are suspended within easy reach and rapidly weld the parts together. Having completed the floor, or what would be called the chassis on an orthodox car, the next operation is to assemble the body's sides. These arrive as two pressings, and being located from the shackle pins as previously, are placed in position. As soon as one side is in position, a jig is placed across the body, which being located off the floor itself, accurately determines the position of the two sides in relation to one another and to the floor. When the sides are fixed, a welder, complete with goggles, gets busy, and in a very short space of time, they are welded to the floor. The roof, which also embodies the windscreen aperture, is next placed in position and is located accurately with the sides by means of a jig ready for welding. As this part of the body is inaccessible to the portable electric welding machines, this operation is carried out by gas welding. This forms a definite location for the roof, and as soon as it is completed, the roof and sides are joined together. Following this, the wheel arch is joined to the body, and operators working in pits at the side of the moving conveyor accomplish this with the aid of portable welding machines. The next operation is to assemble the luggage boot and rear panel of the car. The panel is made so accurately that it needs only a push of the hand to slide it into its permanent position. Here, the ordinary welding machines are not adequate for the work in hand. and extra long-jawed machines are used to enable the operators to reach the seam. The next operation is to fill in the seams which have just been welded together. By means of high-speed wire brushes, the body is first polished and later tinned. As soon as this tinning is complete, the operator, working with a blow lamp and large sticks of solder, commences the filling up process, which is quite an artistic effort. First he heats the solder until it is reduced to a plastic state, and then he dabs it onto the seam. Continuing this until he has sufficient, he smooths out the solder and brings it into line with the contours of the body itself. Using a small wooden knife with deft strokes, he flattens out the rough parts and then blends it into the curves of the molding on the side of the car. The scuttle is the next component to be assembled. This is placed in position, and a series of small clamps, which reminded me of pegs on a washing line, are placed round the edge. These serve the dual purpose of locating it and holding it while the ubiquitous welder is brought into action. The bodies now have numerous small additions made, and passing along on a moving conveyor have any dents or imperfections removed. Except for a few unit assemblies, the body is now complete. The first of these is the boot lid. This is threaded carefully under the supporting bar, pulled up into position, and the extending clamp arm rapidly screwed down. It speaks very highly for the production methods of Morris Motors Limited when you see these parts being brought together and made into one complete body merely by the addition of a few screws. The assembly of the doors is the next operation, and these, like the boot lids, have been brought to the side of the assembly line. Here again, it's very interesting to see the speed with which they're hung. To the ordinary person, this would present quite an amount of labor, but the skill of these men makes such operations appear simple. The weight of the door itself is quite a problem, let alone holding it up and screwing it into position at the same time. However, like everything else, familiarity breeds contempt, and these men can hang a set of doors before you or I have hardly begun to think about it. And so, in perfect order and precision, the bodies enter the paint shop.
Oh, by the way, Dad, is it right they paint the bodies by dipping them?
No, the wings are dipped, but the bodies get their color by spray. First, they receive a number of priming coats, which are the base of the shining color coats. Each priming coat is dried in a kiln and is then rubbed down with a fine abrasive paper. This filling and rubbing down is repeated until a perfectly flat surface is obtained. After this, they pass through a series of booths where they're sprayed with their color coats. Between each spraying, the body is conveyed for a set period through a drying kiln which thoroughly hardens the paint. As soon as the body has received its final gleaming coat, it is allowed to harden and then passes to the body trimming lines. These are continually moving power conveyors, and while on them, the majority of the interior equipment is fitted to the cars. The windscreen assemblies are brought by overhead conveyors to the operators who screw them in position, and the windows and quarter lights are dealt with in similar fashion. The plastic moldings around the doors are screwed rapidly into position while the fascia board and tray are similarly dealt with. The inside of each car is often a hive of industry, sometimes as many as 3 men working inside at the same time. For this reason, the lines often present a very deserted appearance. Slowly but surely, however, the cars pass along, each operator adding his particular part until all are fitted ready for on the roller track, complete with rear springs.
Dad, I thought the engine, axles and wheels were always fixed onto the chassis.
On ordinary cars, yes, but this, Morris, is the latest product of engineering science, and the wheels are fixed directly onto the body. This cuts down weight, improves performance, and makes for greater rigidity and strength. For this reason, most of the assembly work is carried out from underneath the body. Special ramps are built into the track to enable the operators to exert pressure on the springs so that they can assemble the shackle pins easily. At the same time as the back axle is being assembled, such things as the exhaust tailpipe, the bracket cables, Lockheed brake attachment, etc. are being fitted. All the time these assemblies are being carried out, the shell is being slowly but steadily carried forward. At the same time, and working in unison with the body for which it is required, the engine is being prepared on an overhead balcony, and at the precise moment is lowered onto a small track. Arrived here, the operators pull it into the main erecting line, and by means of a small crane, lift it into the body, which by now has arrived at the correct position. Here again, the new method of assembly which has been adopted by Morris Motors is very apparent. The engine is pulled up into the body and located from underneath, as against the old method of lowering the engine into the chassis. While the engine is being assembled into the car body, other operators on the platform above have been busy erecting the front axle, and by the time the body advances a few more feet on the line, this is installed on a small sub-track at the side, ready to be pushed into position as soon as the body is brought there. Here again, a hydraulic ram assists the operators to flatten out the springs so as to facilitate the assembly of the shackle pins. These lines are marvels of organization and perfect examples of modern flow production. Grouped on either side of the line and opposite the points of assembly are stores of various parts. Individual components, small sub-assemblies, and complete units are always to hand. As they are used, they are replaced immediately, so that a continual flow of production can be maintained. At the end of these lines, the body is lowered onto another conveyor on the floor. This is done mechanically, the body being pushed into a cage, and as soon as the operator presses a button, it automatically lowers itself onto the track. From here onwards, all operations are done with the car resting on its front and rear axles. After traveling for a few yards more, the body passes under an overhead conveyor carrying radiator units, and the operator has only to lift it off and locate it onto the car. These conveyors, by the way, are really stores. Containing all types of radiators, they are an unending source of supply for all the assembly lines over which they pass. With the radiator unit now bolted firmly in position, the car enters the final section of the erecting line. Passing slowly along at a uniform speed, the car is fitted with all the electrical equipment that is necessary, which, as you can imagine, is very considerable. To facilitate assembly, the actual wiring is built into the car at a very early stage, and it only remains for the electricians to make the various connections. After this, the wings are bolted into place, the radiator grills added, and the lamps wired and secured in position. Finally, the wheels, which are fed down an automatic chute to the operator, are put on the axles and a hydraulic spanner used to tighten them up. Except for a few internal embellishments, the car is now practically complete. And in order to add these, it is transferred to a finishing line. Here, all outstanding items are added and any adjustments made. The bonnet side leaves are fitted accurately. Here also, all interior comforts are added, such as the rear squab and rear seat. The carpets, both back and front, are inserted and clipped down into position, and finally the front seat is put in and bolted down. As a matter of fact, this is where most of the comforts and refinements you're going to enjoy so much are added. Let's go back to the car and I'll show you what I mean.
Well, I must say I admire your choice, John.
It really is perfect. And it's so nice to know you're surrounded by steel.
Yes, you'll be just like a knight of old.
Yes, just as safe, much more comfortable, and a car I'll be proud to own.